All right, so we're going to look at the following function f of x is equal to ax squared plus bx plus c. And what is not new is how to identify if the parabola opens up or down. Okay, we know when a is greater than 0, okay, we know that the parabola is going to open upward. But what is going to be new here is that our vertex is going to have a minimum value, the smallest value of the parabola. Okay. And then when a is less than 0, we know the parabola is going to open downward. And that's where the vertex is going to have its maximum value or the highest point. So we're not going to graph these, but some examples I'm going to put here. We're not going to graph, but we're going to determine if the graph has a minimum value or maximum value just by looking at the coefficient of a. So for example, we have f of x is equal to 2x squared minus 20x minus 3. Now, when you identify your a, we have 2. We identify our b, we have negative 20. So let's look at the instructions. An equation of a quadratic function is given. Determine without graphing whether the function has a minimum value or a maximum value. Find the minimum or maximum value and determine where it occurs. Identify the domain and range. Okay, so for this first example, since a is a positive 2, we know that this graph has a minimum value. So you know that, even though it says without actually graphing it, but just a visual. So we have a minimum value. Part 2, it says find the minimum value. How we're going to do that? We're going to use x is equal to negative times b all over 2a. So then that would give us negative times negative 20 over 2 times 2. We have 20 over 4. That gives us 5. But remember, when it's asking us to find the maximum value, where does it occur? I want the ordered pair. Okay? So this is still going to be the vertex. So we have the x coordinate, that is 5. So let's find y. We're going to take our original function, substitute 5 in for x. So we have 2 times 5 squared minus 20 times 5 minus 3. 2 times 25 minus 20 times 5 minus 3. We have 50 minus 100 minus 3, and that gives us negative 53. So this is part B. Find the, for this example, minimum value, which we did, and determine where it occurs at negative 53. And then the last part, let's find its domain and range. So I want you to think about it. Our domain for when the x squared is being squared, is negative infinity to positive infinity. But our range, what do you think the range would be? If this is our minimum value, where would this parabola begin on the y axis? So we would say negative 53 to positive infinity. That will be our range. Okay, let's do another example. We're still on the same page here. Let's do another example. We have example B. We have f of x is equal to negative 3x squared plus 30x minus 7. So our A is negative 3. Our B is 30. So do we have a minimum value or do we have a maximum value? Because our A is negative 3. We know that the parabola is going to open downward, so this means we're going to have a maximum value. So let's find its maximum value and determine where it occurs. We're going to use x is equal to negative times b over 2a again. So we have here negative times 30 over 2 times negative 3. That gives us negative 30 over negative 6, and that is 5. So remember, we're looking for the maximum value. It's the vertex, so at 5, we know the x coordinate is 5. We want to find the y coordinate. So we're going to substitute 5 back into the original function for x. Negative 3 times 5 squared plus 30 times 5 minus 7. We have negative 3 times 25. Then this gives us negative 75 plus 150 minus 7, and that equals to 68. This is our y. Okay. So what do you think our domain and range would be for this example, since we have a maximum value of 5 comma 68? Now, here again, our domain will be from negative infinity to positive infinity. But what is your range, since our parabola is opening downward? Negative infinity, comma, look at your y coordinate here. 68, this is where it ends, and we end it with a closed bracket. There we go.